Well, we're glad to have you all here, and this is one of a series of 6 workshops that we're doing around the state. This is actually the 4th one we're doing, and the idea is we're going to rotate around the state and do all 6 in each region. So in this, we did one in Murfreesboro last week on soil amendments, and then we're doing production ag water here, and so in the next 2 years, the other topics will rotate here. So we're doing worker health and hygiene in Memphis, and we're doing post-harvest water in Martin, and then in Johnson City we did a module on post-harvest handling and sanitation, and then in Chattanooga we did soil amendments. So all of those workshops will be rotating around the state, and they're all part of the Produce Safety Alliance curriculum, which is a full-day curriculum that was put together by the Produce Safety Alliance, and as of right now, it's the only FDA-approved course to meet the FSMA educational requirement. So what we've done with these workshops is just break them down into individual modules and added some hands-on components, because the Produce Safety Alliance training all in one day is a lot of information coming at you all at once. So we wanted to break it down and give you time to ask questions, and this is a nice group that if you have anything you want to say, just feel free to raise your hand or let us know.
Guarantee you, if you have a question, somebody else in the room probably has it also.
That's right.
So the learning objectives for this section, and again, we're talking about the water that we're using for irrigation or for fertigation out in the field, also for the water we use to apply any sprays that we're using out in the field, as well as frost protection, things along those lines. So we're hoping that you can identify risks that impact the microbial safety of water sources. That's really the brunt of where the focus is with this training, so that we try and minimize people who get sick from consuming fresh produce. We want you to be able to describe practices such as water application method, like overhead irrigation as opposed to drip, and timing that can reduce those risks that may come with water. Also adopt practices that limit impacts to the environment, soil quality, and wildlife habitat. Describe the importance of water testing. Water testing is a big piece to this, and it becomes an even bigger piece if you're using surface water like a pond or a river. We want you also to be able to describe the FDA agricultural water quality criteria that we'll focus on a lot and goes back into that water testing. Describe actions that could be taken if your agricultural water does not meet the standards that are identified within the regulation. And of course, there's always, if you didn't write it down, it didn't happen, right? And many times people, they hate to keep records, but it's one of those things. If you're going through the actions, it's really helpful for you to be able to document what you're doing on your farm day in and day out. I always like to tell people, even if you're not having to be compliant with this regulation, and even if you're not in the business to get a good agricultural practice audit for your food safety practices on your farm, it's always nice if you're doing something to document it. Just in case if there ever are any questions, you have it right there and on paper, and you know what you've been doing to manage your farm and your practices.
So production water, as Faith mentioned, is any water that's used in contact with the produce during the growing season. And that can include irrigation, fertigation, foliar sprays, and also frost protection.
So the definition says that all agricultural water, or the regulation says that all agricultural water must be safe and of adequate sanitary quality for its intended use. If I just told you that, would you know what in the world that means? You know what you know, a lot of people would say, well, if it's adequate, that means it's on. I can irrigate with it, right? It's there. But in reality, what the regulation is talking about is that you have to have certain microbiological standards that you're meeting if you have to be compliant with the law. In reality, if you don't have to be compliant with the law, these standards are trying to get at making sure that you're not potentially contaminating produce with the water that you're using for irrigation or protective sprays.
So why do we focus so much on water? And in the field, you might think, well, you know, I'm using drip irrigation, I'm fine. This is a good example here, that this is buried irrigation tubing that got hacked, maybe got chewed on by a mouse or something, And so now, instead of being under the ground and right in the root zone, it's getting up on your produce. And it might not be a big deal. It might only be hitting one plant. But if you don't see that and you go in and harvest and for some reason there's contamination there, and then you're putting it in a big dump tank like this one here, or even in a 5-gallon bucket on your farm, that can spread that contamination from one thing to the other. So that's why I want to focus on water, because it's the number one factor in contamination of produce, and it's really a critical point that's capable of magnifying an error in your management during production, harvest, or post-harvest.
So the thing that's hard with production water is that there's so many things that impact its quality. And we also see many different sources and uses of water on the farm. For the growers in the room, how many of you are using a well to irrigate from? Just raise your hand. How many people are using municipal water to irrigate from? I skipped over that one. So a few of you. And how many people are actually using surface water to irrigate from? Yeah, and we see that fairly commonly. We have a fairly good mix as we get to Middle Tennessee. So we'll go through with all those different water types, what the risks are associated with them, and essentially try and make you comfortable with why you're doing water testing and why it's important to kind of give you an idea about, is your water potentially contaminated with what we call human pathogens, but in reality they're just those microorganisms that if people consume them can make them sick. And in essence, as Annette was saying, once these organisms get into the water, that water then is touching a lot of crops all at once, and then you're going to have the risk of contamination just being magnified across your production. So produce safety is definitely impacted by all of these choices that you're making in the way you manage your farm and your environment.
So again, we've talked about the uses. Anytime you're going to have water in your production field, you can be using it for dust abatement. You can be using it for other uses where it might directly contact the produce, in addition to cooling or your crop sprays or frost protection or fertigation and irrigation. And you just want to be very mindful of those uses and where the produce might come in contact with that water, especially if you're using a surface water source, and we'll talk about that in greater detail.
Yeah, I would say the biggest thing that you need to think about within the context of this presentation especially is we're really concerned with where water touches the edible portion of the crop. So some people say, oh, I'm using drip tape, I don't have any risk. Well, are you growing carrots? Are you growing onions? So think about those root crops, even though, yeah, you're using drip tape, with some of those crops you're going to still have risk because that water is going to be touching that crop. So the things that we think about for produce safety connected to production water, the production water source and quality that we'll talk about. Again, we've broken it down to public water, groundwater, and surface water are 3 buckets we like to lump things into. Talk about testing and sampling amongst those different water types. The application method that you're using for irrigation, are you using overhead or drip tape? Again, all within the context of, is that water going to actually contact the harvestable portion of the crop that people are going to actually be consuming? And then the timing of application. Again, are you only introducing this water at planting? Are you also, again, as most times the case is, going to be actually exposing all throughout, even close to harvest?
Especially in the summer in Tennessee.
Right.
So the probability of contamination, we've talked about this a little bit, in the public water supply or municipal water as we sometimes call it, it's going to be treated, and so it's on the lower risk spectrum there. And then we have the groundwater where we have a nice capped well, and that's going to be in the middle. And then the surface water sources that are open to the environment and animals coming in and leaving deposits in there, that's going to have the greatest risk.
So municipal water has the lowest risk for contamination, but it's not used very frequently for production because it has the highest cost associated with it, right? You're paying a premium for that. You should also be cognizant of the fact that, yes, that municipality is definitely managing that water that they're supplying to you to make sure it's what we call potable. So it shouldn't be coming in with any pathogens in it. However, from the point that it gets onto your farm until it's delivered to that crop, there are numerous things that can happen to it, which can lead to contamination. So don't just write it off and say, oh, I'm using municipal water, everything's great and hunky-dory. So always know that things can happen between the water source and actually where you're applying in the field.
So for preventing contamination of municipal water, even if you're using municipal water, you still want to assess your connection to the public water supply and make sure that distribution system downstream is sound and everything's all right. Test the water if you have any concerns about that water source, and then have a backup plan if you think that your water in the distribution system may be unsafe for some reason. And on our farm in Knoxville, we use municipal water, but again, a lot can happen, and we have had water tests that were a little surprising on our farm because we thought, oh, it's municipal water, it'll be all right. But all those pipes that come in onto the farm, as Faith mentioned, a lot can get introduced in there.
So for well water sources, or groundwater is the other term we use for this, is our next type of water we'll talk about. So wellhead is the place where the risk of potential contamination is relatively high. And essentially with the wellhead, you want to design it so that essentially you don't have risk of runoff coming in and actually contaminating that wellhead. So an improperly constructed well provides a point for source contaminants to enter. And usually when people have issues with their well water, testing high for microorganisms, when you go back and look at it, a lot of times the wellhead may be the confounding factor there, that it isn't built up. You do have risk of runoff coming and contaminating that well.
And this is a good example of one that you could get contamination in. So then if you are using a well, you want to make sure that the runoff from that well is diverted away from your wellhead. You also want to make sure that the casing is going to extend above the ground, because that's going to help prevent any contamination getting in. The outside of the casing should be grouted to a depth of greater than 25 feet, and then that casing should be surrounded by a concrete pad. And it's important to put as much distance as you can between your water source and your potential contaminants. So you just, again, if you're using a well, you want to inspect that system every year before you get started. And so you can see if any problems have arisen since the last season.
So when we're thinking about prevention of contamination of groundwater sources, we always want to make sure we're inspecting the well to ensure it's in good condition. Inspect that wellhead to ensure it's properly capped and, again, elevated. As you can see here, that we actually have that ground built up slightly. Be sure that land slopes away from the wellhead, as Annette just mentioned. Again, we're just trying to prevent contamination from running into that well casing. And then also install backflow prevention devices to prevent contamination.
So with surface water, do you really know the quality of your surface water? It can change pretty quickly, and this is especially true of surface water versus other sources. So it might look like this right there on your farm, but upstream from you a little ways, it could look like this, and your neighbor's cattle are going right through that pond, right? And so water testing gives you that snapshot of what it looks like on your farm, but with surface water especially, you really want to know what your neighbors are doing, and you really want to be part of that conversation if you can. Here's a picture from the flood, so that's another situation where you might have a surface water source, and usually it's within its bounds, but we know from Nashville in 2011 that can change pretty quickly and have drastic repercussions.
So when we think about potential sources for surface water contamination, they are numerous, right? Because it's an open body of water, and whatever comes in contact with it or whatever runoff is exposed to, we're going to drag it into that water. So essentially we have wildlife and domesticated animal feces that are pretty easy to think about, as Annette just mentioned. Manure application, though, and composting operations. Again, you have people spreading manure just to distribute it, and that's going to be coming into your surface water. Other ag-based runoff, again, it's a lot of times going to be taking some of these pathogens with them. Onto the other side of septic tank leakage. You know, are you into those leaching fields where you're actually going to get contamination into surface water? Wastewater discharge, urban and environmental runoff. We're seeing people farming closer and closer to really highly densely populated areas or on repurposed land. and the issues that could come with that. By using that as farmland is something to be cognizant of. And then honestly, there are plenty of other things we honestly never even thought of that people kind of come up and tell us stories about, as far as like, hey, I had this happen and we tried to figure out what was going on here. And it's like, I never would have thought that would have been an issue.
That's the catch-all, things we never thought of.
Yep.
So preventing contamination of your surface water sources, as we mentioned, you want to assess nearby land use, what's going on around you in upstream water activities to identify any risks. Work with your neighbors, work with the local watershed groups to understand and minimize any risks that there might be. And then you want to assess and address any runoff risks to your farm. So that might mean developing a diversion ditch so it's running away from your crop field, or berm, or containment to minimize that environmental runoff. And then any runoff from manure and compost piles. You want to really think about where you're putting those compost and manure piles on your farm. And runoff from livestock feeding areas. So if you're a mixed operation, that can really come into play there. And then you want to monitor and control animal access to irrigation water sources where practical. So those are your irrigation reservoirs. We did some work in Crossville, and we did it specifically there because we wanted to use the cattle pond because we knew it would have these foodborne illness pathogens in it. So it was a great place to do that work because we have the cows there on the station, and then we planted our vegetables right there. And for our purposes, that was ideal because we wanted that contamination in the water. But as growers, you don't want that contamination in there. So if you can keep the animals out of that water source, that's better for you.
Yeah, and a lot of times even working with your neighbors to try and work with them, say, hey, can we possibly build a watering trough, an automatic watering trough for the cattle and fence them out of the creek that I'm pulling from. Something along those lines is a really good example where people have negotiated that in the past. So going from water types to how you're actually exposing the produce to water is what we're going to talk about next. So when we think about irrigation specifically, we have overhead irrigation. And in general, we say that this is a higher risk. And why is that? What do y'all think? Yeah, it's a direct contact. So, we can always talk about, with root crops and drip tape, you may have some contamination risk there. But if you're talking about overhead, then, it's definitely going to be coming in contact with any produce that you're growing. So you're going to have that direct contact that we've been talking about to think about within this rule. You can also have flood. We don't use this in Tennessee, but again, where you actually flood the field. And again, it may avoid direct contact with produce and consider the risk of contact with contaminated soil in those flooding practices. Drip tape is the other type of irrigation that we commonly see. And again, we typically think of drip as being lower risk. And those are for those crops that are grown above ground because it's not going to be coming into direct contact as long as that drip tape has good integrity. And so be thinking about that. That's not always the case. And many times when people are reusing drip tape, it's easy for it to get hacked up over time. But always with drip tape, with root crops, it doesn't matter either way.
And we always, for every one of these workshops, we've said when you're doing something that reduces your risks for food safety, you're also improving or maintaining good production practices. So sprinkler or overhead irrigation, we don't generally recommend that for most crops because all that moisture on the fruit canopy or the leaf canopy can contribute to plant pathogens as well as foodborne illness pathogens. So you don't want your plants to get diseased, and that's going to help reduce it if you have that drip irrigation that's keeping that water right there in the root zone where the plants are going to take it up and off of the plant itself. So it's always a 2-for-1. You're doing some practice for good production, but you're also getting a food safety benefit out of it.
Let me the root system then filters out the pathogens.
That's a great question. The question was, does the root system filter out the pathogens? And I'm going to let Faith answer that one.
So the answer is no. We've actually seen
There's some interesting research on that.
I was asking, so in essence then, what is going to be the advantage of the drip tape?
So the drip tape has an advantage because it basically will help the plant develop faster. And Annette can fill in there, but essentially you get faster plant growth and better production.
It's more water use efficient. But from a food safety perspective, you're asking.
Yeah. From a food safety perspective, you can have introduction through the root zone. We've seen this when people manipulated it within the lab. Again, they're introducing relatively high numbers through those root zones, but we have seen definite uptake in it making it into the crop. So those plants can work in that fashion, as observed through trials we've done in the lab.
But were those really spiked with really high levels? Or
They were typically spiked with higher levels, but you could argue the fact that if you have a slug of a biofilm breaking off, it could introduce really high levels of a pathogen in that root zone.
Yeah.
So for pre-harvest direct versus indirect application, again, just to kind of hit, is it contacting? So indirect application, we have irrigation of drip and furrow irrigation or fertigation through that drip tape. For direct contact, overhead irrigation, a lot of people focus on the fact, I use drip tape, I'm good to go. But then you ask them, well, what water are you using for your sprays? And they're like, oh, and it's like, yeah, you're using that same water, right? So that water is going to come in contact with the edible portion of that crop. So think about that. Again, compromised drip tape, even drip tape with root crops, and definitely frost protection. Again, if you actually have the edible crop formed when you're frost protecting, would be a risk there.
So we had lettuce in our high tunnels, and we had an intern from the UT farm help us harvest last week. And my research associate and I were in another tunnel taking yield data, and he just harvested that lettuce like wildfire. He went through there, and my research associate went back and said, oh, I don't think you helped. He hacked up our drip tape with every lettuce plant that he cut off. Just hacked the knife right into it.
He was really good and deep.
Yes. So this is where we talk about SOPs and making sure somebody's doing it the way you would do it, because that's not the way we would have done it. We were very careful with our harvesting, and he came in, and boy, he was done in a very short amount of time, but we're going to pay the price and have to relay that drip tape because it's just hacked beyond any fixing. So generally, we're gonna have the idea that less water contact is going to equal lower risk. And even in a system with drip irrigation, it's contacting the roots, but it's not contacting all of the foliage too, and it's not actually contacting the edible portion. So again, it's not having as much contact there. So you want to think about, is it applied directly with a direct application method? If the answer is you're never applying water directly to the crop, then the risk from water is going to be very low. If the answer is yes, it's going to depend on the commodity. It's going to depend on the quality of your water, which can change throughout the season, and whether it's a cool year or a hot year, and whether it's a rainy year or a dry year. And then the timing of your application should be reviewed to assess risk. Again, that one, if your crop needs water, you can't hold back the water and still get a good lettuce crop. You're going to have wilted lettuce. So it always has an element of common sense in here as well.
So one thing you'll notice is built into the regulation is the knowledge that pathogens, once they're out in the environment, it's not their ideal place to live. They're not nice and warm and happy. So essentially, we do get inactivation or die-off over time. So what drives this is things like desiccation or drying out, sunlight, and again, it's only when they're exposed to the ultraviolet irradiation in the sunlight that you'll actually see that working. Temperature and humidity many times may not be ideal. Starvation and actually out competition from other organisms that are suited for growing in the soil or on the plant surfaces is going to be key there, because there are only so many nutrients that they're kind of all competing for. Some pathogens are always going to be protected. There's always nooks and crannies, even in something like a tomato where you're like, nope, it's nice and it's, it's not like a cantaloupe or anything like that. There's plenty of nooks and crannies when you actually get in there and look at it through a microscope, because, something like a microorganism, we can fit 1 million of them on the pinhead that you're holding in your hand. So they can really get in and hide in a lot of places. And that's really hard to conceptualize for a lot of people. But there are always going to be areas where they're going to be protected. And under some conditions, pathogens may start to die off, but then all of a sudden conditions get better and they may actually start to regrow. We've even seen this even in temperature dips throughout the day and humidity dips and increases where you'll actually see them kind of starting to die off and they may pick back up a little bit as that temperature becomes more what they would like. Also, if you have something like a plant pathogen that actually, essentially these things like nutrients to grow, so those plant pathogens may come in and actually start to decay the fruit or the vegetables, give them access, these foodborne pathogens access to that sugars in there, and they're going to grow like gangbusters once they get to that sort of condition.
We always talk about the pathogens. You don't want to water at night, especially if you're using a hose for the gardeners. When I give gardener talks, and hose them down right in the evening when it's cooling down, you think, okay, it's cooling, they're not going to wilt. But then that temperature's cooling down, you just introduce moisture in there, and it's like a party for the pathogens. So they can go wild all night while it's those nice 70 degrees and you've given them the moisture. So you want to inspect your agricultural water sources and the distribution system. We've already touched on this a little bit. It can be contaminated at the source or it can become contaminated in the distribution system. So you don't want to just think, okay, my source is good. And we ran into this in one of our studies where we tested the water from the pond and then we tested it after the sand filter and then we tested in that lay flat drip tape. And we found that we were actually getting higher numbers at the end of that drip tape because it was a year that we were running the irrigation only once a week. Because it was a project where we wanted to irrigate, we didn't necessarily need to because we had plentiful rain, but we also had nice hot temperatures in between. So that lay flat had water sitting in it for the week and got a nice biofilm growing in there over that time. So you want to map all your water distribution system, and then your water sources and distribution system, you want to look at that at least annually. And you want to keep your sources free of debris and trash and any domesticated animals and other hazards that might get in that system. So just like you go around and scout your field, you want to scout that distribution system.
I've got a question about that. Are you going to go in later at all into how to mitigate risk for that growth inside of lay flat and drip tape?
Yep, we'll
We
get
are,
to it.
yep.
Okay.
And we have a nice trailer demo outside, and we're going to talk about all that.
Okay, great.
So yeah, so that
After.
question was, are we going to get into actually how to mitigate risk within the distribution system, so that you maybe find up at this point source, but actually have biofilm formation in your lay flat and things along those lines, or drip tape.
Mm-hmm.
So when we're evaluating water quality, the only way we know if our water is of sound microbiological quality is to evaluate through testing. And we actually have to do what we call a quantitative test, which is just a fancy word for counting. So we're actually getting a population of microorganisms. In essence, records become very important in the event of an outbreak investigation. So showing that you've been testing your water and that definitely if you're having to become compliant with the regulation, you're testing your water at the proper frequency. Document the results of each water test for comparison purposes. You want to be tracking this so you can trend it over time. We'll see people that if they're using surface water, their surface water is going to kind of be hitting steady state. And then all of a sudden, they'll start to see spikes in their numbers. And a lot of times, people think of rain events causing spikes in numbers. But honestly, when we seen, Annette did a couple year study where she went around, tested a lot of different irrigation water sources. And some of her highest numbers actually came in when we had drought seasons. And it's because, again, you're concentrating that water, so you're not diluting them as you normally would.
And it's nice and warm in there.
And it is nice and warm. So by tracking these changes, you may be able to identify problems. And again, it's not only for safety, but it's also going to help you for production. And that always says that what benefits you from a safety perspective many times is also going to help you out in mitigating those plant pathogens that can also rear their ugly head and really cut down on your production.
So the nice part of that is things you're probably already doing are also giving you the food safety benefits. So it's not like you have to change a massive amount of things you're doing. You're already doing a lot of this for good production anyway. So now we're going to get into a little bit about if you're going to sample for your water, where are you going to take that sample? And you really want to collect that water sample as close to the point of use as possible. If you are using a surface source and you take it right out of the stream, you're getting that quality in the stream, but if you have a sand filter on there, that could be taking some of those pathogens out. So you really want to get it, and then the issue we had with our lay flat and building up those microorganisms over the week between when we were irrigating, you really want to take it right where it's going onto the crop so you know the quality of the water that the crop is receiving. And then you want to select a sample area that's clear of dense litter or vegetation.
So whenever people want to sample water, a lot of times I think they can just walk out and grab a water sample and fill up a Ziploc bag and send it off to the lab. And that's not going to be the case. You're going to want to establish a relationship with the lab up front, and to essentially they'll give you your water sampling bottles. They'll give you the specific instructions about how to actually take the water sample. The bottle that you receive is going to be a sterile bottle, so there's no need for rinsing or anything like that. And then they're going to tell you how much water you're going to need to put in the bottle, and then they're going to tell you what's your time frame for getting that water sample to them. Many times you're looking at overnight express delivery with ice packs in there to make sure that water, essentially with the microorganisms, we don't want to keep them out at room temperature because they could actually increase in numbers during transport. So the things you'll want to do is definitely label the bottle with an identifier so that when you get the results back, you actually know what that water represents, because many times you're not just pulling one sample, you may be pulling a couple samples. When collecting samples from equipment, so if you're running the irrigation line, let that line run for a minute or two and then collect your water sample so that the system actually gets up and gets running.
And then you want to take those samples, as Faith mentioned, and usually you're going to put them in a cooler with ice packs, so you're minimizing that microbial growth. And then you want to deliver them to the lab as soon as possible, and generally, as Faith mentioned, overnight or within 6 hours. Again, you want to check with your lab for specific instructions. Most labs are going to be similar, but again, you want to check with the lab that you'll be using. We had the publications on the back table about water testing and interpreting your results, and we did those pre-FSMA, but it has a list on the testing one of labs in Tennessee that'll do that test for you.
And we actually have a lab who's agreed for this people who are participating in this workshop who are growers, that they would give you one free quantified, one of the water tests we'll cover here in just a moment. So again, we'll check with you all at the end of the after dinner tonight, and we'll make sure that if you want to opt out of that. Otherwise, we'll pass along your email address to the lab. It's Waypoint Labs, and they will be contacting you about how to get that water test result.
Let me ask you another question.
Yes, sir.
What about chemical impurities?
Yeah.
I mean, that's just, because basically we've been talking about biological so far.
Mm-hmm.
Yep. So the question was, what about chemical impurities? You know, definitely we can have issues with things like heavy metals and things along those lines coming into the water system. And again, this regulation does focus a lot on microbiological hazards, because from a historical perspective, that's been what's caused the actual food safety and health risks to people. What I would say from other chemical impurities causing issues, be cognizant of the land. You know, if you're using repurposed land, has there been a point source contamination or something along those lines? Many times it's not so much the water as it would be the soil and things along those lines that we tend to see those issues with. Additionally, you know, kind of knowing your farm history is the biggest point, and what also is going on around you. You know, if it's definitely a regulated industry upstream from you or something like that, then they should be adhering to all EPA regulations. But you may want to kind of have a conversation with.
I know, like Stauffer and Montana. Like I said, I'm from Hickman County, Lewis County, in that area.
Mhm.
And Stauffer and Montana, their waste, they drilled wells and injected their waste into the ground. So you know, who knows where that goes?
Yeah. Yeah, I mean, I can't really speak to it. I'm not, I mean, yeah. And so I'm not really familiar with that scenario, but it is something to think about and to try and assess. You can definitely have testing beyond what we're talking about done through analytical labs, and they can tell you if there are, what your risks are associated with that.
That would tend to be pretty expensive, though,
Yeah.
because you're going to have to know what you want tested for, and each one of those are going to have an additional cost. So what are the parameters that you should test? For the FSMA rule, the thing that they're interested in is the quantified generic E. coli. But oftentimes when we get a water test, and what we tested when we did the water studies around the state, we also got a test that gave us the pH of our water, which is important for if you're using sanitizers, which is something we'll talk about tomorrow night, mostly with the post-harvest water. But you want to know the pH of your water so you know if something's going wrong there. If you're a greenhouse grower, pH is very important. And then the conductivity and the turbidity of the water can also be important from the production side as well.
So when it comes to the regulation, a lot of people say, okay, what water test should I be having done? So the FDA initially had only identified one test that was allowed, and it was the EPA method 1603. And in essence, this was a filter-based method where essentially that's the filter right here. You load your 100 milliliter water sample through here. Microorganisms get caught on the surface of this filter. And then essentially it's incubated under very controlled conditions. And you count the number of colonies that come up. And it tells you what your generic E. coli population is. But there are a lot of different other methods that we can utilize. They're all recognized as equivalent to this gold standard method from the EPA's perspective. A few of those, which are on the next slide that Annette will talk about, have actually been identified as being equivalent from the FDA's perspective. So make sure you're either having this method 1603 or
the methods that are on the next slide. But this is the very important thing. Even though they've gone back and improved some of those methods on the EPA list, don't just look at the EPA list and think you're golden, because not all of those are considered equivalent. So you really want to make sure it's on the FDA's list and not just an EPA list. So these are the methods that the FDA has determined are scientifically valid, and those are going to include membrane filtration methods, as Faith just talked about. So MTEC agar, and then MI agar, and the M-endo, NA,
MUG.
mug agar, and then the M Cola Blue 24 agar are all equivalent methods. The ones that we've used most commonly when we've done tests here are ColaLert QuantiTray. And so if you're going to a lab, you want to ask them what method they use to quantify that generic E. coli and make sure it's going to be on this list. But most labs in Tennessee that we've worked with will use this ColaLert system, which is now accepted.
So the next question people have is, okay, where do I go for testing then? And in essence, we're not in the business of promoting one lab over another. Essentially, it's going to be a lot of people shop around based upon price and what the labs are able to it's a working relationship, right? You have to be able to get the results you need in a timely fashion. And again, have the responsiveness that you need. So make sure that they're going to definitely be doing one of those recognized tests is most important. Again, many of these tests, you may have water, especially for surface water. If you ever get something that says greater than and a number, well, that's not good. Yeah.
Too numerous to count is what we used to get on our samples that were like that.
And so that means that you may actually need to work with that lab to actually get what the exact number is. Because in essence, it's just telling you, okay, it was above what we could actually count. And there are ways that they can give you that exact number, but it takes extra work. And it may result in an extra fee for you for that test.
But it's not good if it's above what they could count.
No, and generally speaking, it's not great news. Be sure that lab provides sampling instructions. Again, this is not something that you're going to have everything you need in your pantry. They're going to give you the sampling bottles. They're going to give you specific instructions on how to get that sample to them and what the time frame is so that you know what you need to do on your time.
And do you want to talk about the little tablet that might be in the bottle?
Yeah, some labs will actually send a tablet in the bottom, which is meant to neutralize, especially for municipal waters, or if there is a sanitizer in the water, it's meant to neutralize that sanitizer. And a lot of people think, oh, I need to dump this out. Whatever's in the bottle, leave it in the bottle. It's meant to be in the
there for a
bottle,
reason.
so just let it be in the bottle. It's definitely meant to be there. Don't rinse your bottle. The other thing when it comes to actually grabbing a sample, it's sterile inside that bottle. So when you're grabbing your water sample, you don't want your hand all inside the lid or anything like that, because guess what? You're going to then get a pretty good idea what the microbial content is of your hand and not necessarily of your irrigation water. And although you probably wouldn't want to admit it, your hands may be kind of nasty if you're out working in the field. So think about that when you're grabbing these samples.
So you really want to think about the lid, how you're taking it off and that you're not touching the inside of that lip of the container, and then where are you setting that lid and how are you setting it down if you're setting it down while you're taking that sample. So you don't want to set the inside of the lid down on the ground or anything like that. You want to make sure everything stays as clean as possible. So interpreting your water test results, from a pH perspective, we're measuring the hydrogen concentration in that water, and a low pH can be caused by acids or acid-generated salts or dissolved CO2 in the system, and high pH can be caused from carbonates or bicarbonates, hydroxides, phosphates, silicates, and borates. We tend to see more on the high pH side than the low pH side here in Tennessee. Water samples that are less than 6.5 in pH or greater than 8.5 in their pH should be checked to determine the cause of the abnormal values. So generally, all of the ones we tested were within that range. We only had, I think we had one on the low end and one on the way high end that was above 10. And then you want to check water with pH less than 6 for the corrosion potential on your plumbing or your pumps or your storage tanks. So you don't want it to eat up your pipes as you're going along. And again, this from the production side, you want your water to be in this range as well to produce healthy plants.
For conductivity, again, with conductivity, what you're doing is the measurement of the availability of water to conduct electric current. It's an indicator of the overall salinity and mineral content of the water, and it's measured microhommes per centimeter, and the values typically range from 0 to 500 as far as excellent for irrigation water. 501 to 1500 are considered good, 1501 to 3000 are considered fair, and 3000 to 5000 are really considered poor for irrigation water. And Annette can probably speak to this more so since I'm the stupid microbiologist, but essentially, if you're using something like high tunnels or something like that where you may have, I know I've heard Annette talk about salinity building up. Again, this is going to be the same thing here where you're not going to have all over good production conditions for your plants.
Yeah, and if anybody's a greenhouse grower, you know that taking your conductivity as your electrical conductivity is like a daily task in there. And they're very particular about their electrical conductivity. And this is why, because you don't want to get those plants too saline. The next thing we look at is the turbidity of the water. So this is the suspended and dissolved solids within that water, and that can interfere with microbial activity. So if you are adding chlorine into your irrigation system or something, anything that's in there is going to interfere with that activity. And the more turbidity you have, the more it's going to interfere. So the usual units of measure for this are FAUs or NTUs. And you can see, not so good with this lighting, but this is when we have clear water. And then as you get organic matter in that water, it tends to get darker and darker and darker. And that's the turbidity we're talking about. And if you take a surface water sample, you might notice, depending on where you took it and what's going on in that water source, that it's going to tend to be on the more turbid side than if you're using municipal source, which hopefully is in that 0 range there. And this can be important if, again, if you're using a system that's going to have a chlorine or something in that water, it's going to make it work harder. And this is an example. I'll let Faith talk about this, but this is an example from a post-harvest situation. but I thought it gave a good representation of the pathogens in here.
So essentially, this is looking at that turbidity number. So as we go through, as the turbidity increases right here,
Which you can see isn't even that dark on here.
yeah, I mean, that 150 is roughly like a very light tan color. You can definitely still see through that water. It's not, for irrigation water, it's not that dirty. It would have some, clearly some suspended solids in it. So if we're looking at salmonella in wash water, we can have here with 25 parts per million chlorine, and then we also have 50 parts per million chlorine. Essentially, this is the time it actually takes to inactivate. So you can tell once we get into having actually some dissolved solids in there that we do see longer inactivation times. Now, there's some things that help drive this. You'll notice that this is actually in degrees Celsius up here, but this is degrees Fahrenheit. So the higher the temperature, we also see that benefiting us, and we actually get faster kill when we're looking at chlorine. Again, we see that even with increasing the concentration 100% from 25 parts per million to 50, we're still seeing that same effect and that same trend going on here. We still see it takes much longer once you start to see more and more dissolved solids into that water.
So evaluating water quality using the microbial water quality profile, and this is the catchphrase in the FSMA rule. Again, testing is the only way to quantitatively evaluate the microbial quality of your water, and the microbial quality profile can really help you understand the long-term quality of your water source and understand appropriate uses for each source, and then determine if any corrective measures might be needed if the quality profile is exceeding the numerical geometric mean and
Statistical threshold
thank
value.
you. I'm drawing a blank there on STV criteria in the FSMA produce safety rule, and we'll talk about these more on the next few slides.
So for quantified generic E. coli,
Why is that what we're testing?
yeah,
basically?
why are we testing for that? So I like to talk about bacteria like they're my friends because I spend a lot of time with them in the lab.
She likes to anthropomorphize them.
Yeah. So we have groups of bacteria that E. coli is a member of. So this little guy down here, these are like pathogenic E. coli that actually can make people sick. And they're a really small subset of this overall family. And so an E. coli fits within this group. If y'all have ever heard of E. coli 0157 that a lot of people think about cooking your hamburgers well done and things along those lines, that's the type of pathogenic E. coli here. But we also see outbreaks with that in fresh produce. E. coli is a generic E. coli, which is what you're actually going to be testing for in your water, is basically an indicator because as we see the populations of generic E. coli increase, the likelihood of actually getting a pathogenic E. coli within that water source increases relatively. So that's why we're looking at that. Other people will say, well, I've been testing for coliforms or for fecal coliforms. Why have I been testing for that? Well, it's because they're actually, E. coli is a broader member of fecal coliform group. And in essence, the big group, which encompasses a lot of microorganisms, are called coliforms. So they're all relative to one another. But in general, the generic E. coli that we're testing for is an indicator. If you have a generic E. coli count that comes back 300, does that mean you definitely have pathogens in your water? No. But as those numbers get higher, your risk of having a foodborne pathogen present does increase. And that's why we're testing for that as an indirect indicator of what is our risk with that water source.
And it's not only the pathogenic E. coli, it could be the salmonella that we talked about on the previous slide. So all of those foodborne illness organisms that we're interested in, if we're seeing the high generic E. coli counts, we could have higher levels of other things besides just E. coli 0157. So water quality criteria that we used for growing activities applies to the water that's going to have direct contact with that covered produce on the FDA list. Each source of production water must be tested to evaluate whether the water quality profile meets this criteria. And that criteria is 126 or less colony-forming units of generic E. coli per 100 milliliters of water, for the geometric mean and less than 410 or less CFU of generic E. coli per 100 milliliters of water for the statistical threshold value.
So a lot of times people think about, what in the world are these numbers getting at? Like, is the geometric mean an average? And, you know, what's the statistical threshold? Like, I'm not a statistician, I grow produce. So what I like to tell people, if we took everybody's height in this room and we said, okay, our average height is 5'6", does that mean everybody in this room is 5'6"? No. In fact, very few of us are 5'6". But in reality, we have, most people are kind of around that 5'6" number. It doesn't tell us what exactly our number is on any given day. It just kind of tells us what the population tends to be. So that's kind of equivalent to a geometric mean. Now, if we wanted to look at our heights across the board and say, okay, I want to know what the 90% of the people in this room, how tall are they? You know, what's our height? So we should say, okay, it's 6'2". You know, if we said 6'2", that means 90% of the people in this room. So how many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so roughly 2 of us would be above 6'2", and the rest of us are going to be below that number. So in essence, that's what these numbers are getting at. So they're telling you what's the rough mean or center of your data for your water that you're going to be taking over time. So you're going to have multiple samples and you're trying to trend those. And then when we're talking about the upper numbers, what do those look like? And most importantly, you're not going to have to do this by hand. There are tools for helping you calculate this that we'll cover. So, tools for helping you establish your microbial water quality profile. This is an Excel spreadsheet tool that comes from the Western Center for Food Safety. And this is an Excel tool, and it's nothing more than you would actually take your data sets and you put in what your survey stage is, and we'll get to what that means in a second, the sample date, the sample location or ID number that you want to use, and the overall sample number. And that's essentially going to be either 1 through 4 or 1 through 20. For generic E. coli, these are the numbers that the lab will actually give back to you. So they will give back a specific number. So I was just making up this data set here. And in essence, that'll give you the population there. As microbiologists, we always like to make things more complicated than it probably needs to be. So we like to transform things to log base 10. And so that's what it's doing in the second column. Don't worry so much about that. But essentially, this data set, on the flip side, is going to take your data and aggregate it and tell you what your geometric mean is, as well as what your statistical threshold value is. And so you're going to know, are you within the requirements of the regulation, or are you outside of that? So most people are going to find this to be very helpful when they actually go to start compiling their data sets. The other thing it does, which is pretty nice, is it tells you at red flags, and I say red flag, it's really a yellow flag, if you aren't meeting either one of these criteria for geometric mean or statistical threshold value.
So here we're not.
And yeah, I made a bad case scenario for this one, so it would red flag us.
All right, so now we're going to talk about the requirements by water source under the rule. And for public water supply, all you need in your records is a copy of the test results or a current certificate of compliance from your municipality. With appropriate documentation, there's no requirement on your end to do a water test that meets the requirements for the public water supply. But again, it's often a good idea to take a baseline sample just to see how it's coming out at your farm, where it's coming out on your crop.
For our groundwater sources, so our well sources, the requirements are that you have 4 more times during the growing season over the period of 1 year to establish your baseline for your microbial water quality profile. So 4 water tests in 1 year. After that initial year of establishing that baseline, you're going to then take 1 sample per year. And so this is per wellhead. So know that if you have multiple wells, then you're going to be multiplying this. So you'll have to establish a different profile for each well that you have. Again, with these profiles, they need to be representative of use. So you don't need to be going out and grabbing your samples this time of year unless you're actually in production. And
Unless you're in a high
to,
tunnel.
Right. And they need to be collected as close as time as practicable, but before harvest. So you actually need to have this water sampling done before you actually start harvesting. A lot of people ask, well, I grow multiple crops. What are we talking about here? So I would say you're better off trying to establish that truly over your entire season, but you're going to want to grab those samples, begin grabbing those samples before you actually start harvesting whatever crop's going to come in first.
And then the surface water sources. So if you need to be compliant with the rule, the water quality profile requires that you take 20 samples or more over a period of 2 to 4 years. So the minimum time is over 2 years and the max is over a 4-year period. So 10 samples a year or 5 samples a year, depending on how long you're going. And then after that initial water quality profile, you have to take 5 samples, and that's going to be every year for your rolling quality profile. So your first 5 will drop off and the next 5 will roll in to calculating that geometric mean and the statistical threshold value. Again, same thing as with the groundwater. The samples must be representative of use and collected as close in time as practicable to, but before your harvest. So for the big guys, this is where they were really getting heartburn on this rule, because if they have 10, 15 water sources and 20 samples over time, that can really add up. And again, a lot of folks rent land, so if they're moving around from year to year and having to do that water quality profile for multiple fields, it can really add up.
So you don't just need to put your test results in a file folder. You need to actually enter them in and start analyzing them, start collecting that data. And when your test results come back high, try and figure out what's going on. Try and decide what's causing that trend. So look at your water sources. Did you have your neighbor next door all of a sudden start spread manure and it hadn't been happening in the past? Do you have, flyways or something like that from wild birds coming into play? Incorrect or inadvertent cross connections, causing contamination back into your irrigation water. Wellhead being impacted in some way, shape, or form. And ultimately try and determine what may be causing those spikes in those numbers or just overall trending high numbers.
So the corrective measures, there's 3 different types of corrective measures that are allowed if that water quality profile doesn't meet the quality criteria. And the first one is to apply a time interval for microbial die-off. So this is between the last application of water and when you're going to harvest that produce, and between the harvest and the end of storage and or the removal activities such as commercial washing that you might be doing. The next one is to re-inspect the water system and identify the problems, as Faith mentioned, and make any necessary changes, and then confirm the effectiveness that whatever changes you made actually had the intended effect. Or you can treat the water, and we're going to talk about treating the water extensively after dinner and ways you can do that.
So with water application and timing, again, we start to see that die-off of microorganisms typically. So what this corrective measure lets you do is to use a microbial die-off rate between the last application of that water and harvest. And the most amount of time you can take is 4 days. So again, with that calculator, that was included. When it red flagged us, it told us we had 1 day that we could wait from the last application until harvest if we were using that irrigation water.
So that's where that log stuff comes in handy.
It does, and again, we don't expect you to necessarily become junior microbiologists. A lot of these tools are building that in.
And we can go back and look at that.
Yep, so right here, it was saying how many days are necessary, because we were flagged, how many days are necessary if using microbial die-off between last irrigation and harvest, and it said 1 right here. And I've put in some really, really high numbers, and you really have to push it to get it above 4. So most of the times you will be able to take this, but again, some crops are really sensitive, especially in Tennessee in the dead of summer, and you may not have anything that's worth selling if you don't irrigate in that period of time.
So does anybody see any issues with this? This tells us we have to wait 1 day before we harvest this crop. But with water samples, you're taking it, you're sending it off to the lab. You're not getting immediate results back. And in the meantime, you might be harvesting crops that you watered produce with. And then you get those results back. And
Yeah, it kind of knowing it's written into the regulation from a risk mitigation standpoint. It doesn't make me feel very comfortable if it was my farm and my business, taking that as my corrective measure.
were you done with that one?
Yeah.
Okay. So if you have unintentional water contact with your crop, again, we talked about if you get hacks in your drip tape like we now have, or you have broken emitters or other water application issues, do you know the quality of that water that contacted the crop, and how close is the harvest to when that water accidentally made contact with the crop? And then human mistakes. If was there a spray application that was accidentally mixed with an untreated water source? Did you forget to turn off your irrigation pump and you flooded your field? And then genuine flood events. So if produce has come in contact with flood water from overflowing streams or open bodies of water, it's considered by the FDA to be adulterated and cannot be used for food. So if you have flood water that came in contact with that produce like we did in 2011, there goes that crop. It can't be used. And contact with floodwater that is not part of a natural disaster may be subject to provisions of the FSMA Produce Safety Rule. So with floodwater, you can have any number of things in there, right? There could be gasoline, there could be oil, there can be
A lot of things that we would
Lots
not
of
normally
things
see
that we don't
with
want
a surface water source.
in there, and it's having contact with that crop.
So for reinspection, again, if there's a problem with your water, be cautious until you know more. And I would say, though, that's easier said than done, because ultimately you have to still irrigate, right? It's not a perfect world. You don't want to keep your head in the sand, though, is in essence what you want to make sure you're not doing. Look for those contamination sources that we've talked about: manure runoff, wildlife patterns, septic tank leaching, things along those lines. Use corrective actions that address contamination sources under your control. Always keep in mind that you may have some local regulations or state regulations that are also needing to be compliant of, especially when we start thinking about a lot of growers are leaning towards treating their surface water sources, especially if they're using that for irrigation. It's not one of those things that you can just blast this with a lot of chemicals. You actually have some ramifications, boundaries that you have to stay within that we'll speak more to. Implement strategies for preventing contamination from happening. Things like Annette was talking about initially, diversion ditches, berms, things along those lines that you can help for the waterways which are under your control. And confirm that changes were effective. And actually, what does that mean? Well, retesting your water to make sure those numbers are trending back down.
So for treating production water, any chemical that's used to treat your water must be EPA registered and labeled for the intended use. So you want to make sure if you're treating irrigation water, you're getting a chemical that has that label on it. Non-chemical treatments called pesticide devices by the EPA may be used if they adequately reduce microbial risk. So these are things like UV lights and filter units and ozonator units.
Ozone generators.
I'm getting all the tongue twister words in these. You should avoid water treatments that may have negative environmental impacts and soil quality impacts. And you want to keep records of all your treatments and the monitoring that you're doing of those treatments. And John Buchanan, who's there in the back, is going to talk about this after we eat and show you all of our nice little treatment trailer.
Yep. So if we're thinking about surface water, what we need to do is initially establish our microbial water quality profile over 2 to 4 years. And so if you're going with 2 years, you're going to have to collect how many water samples a year? 10,
Yeah.
That's right. If you're going with 4, you can do it 5 years. After you establish that initial microbial water quality profile, You then go into collecting 5 samples a year. So that's what, and this is every single pond. Even if I've heard of people like taking from a well and putting it into a retention pond. Well, guess what? When that happens, it's now surface water because you're holding it in that retention pond. So you would have to still follow this protocol. Again, you're going to be trending that water and looking at how that statistical threshold value and geometric mean looks like over time. As you add in these new samples, for every new sample you add, the oldest one rolls off, so you're always working with a data set of 20.
And then for groundwater, same thing. This is just a recap, but it's a little confusing and hard to keep all the moving parts. So this is just a recap of that. At the start for groundwater, you need to take at least 4 samples in a 1-year period. And then annually after that, you just need to take 1 sample of that groundwater. And then those corrective actions, if you see anything, and if that profile doesn't meet your geometric mean or the statistical threshold value.
So for our compliance dates, they were extended for water compliance, so a lot of people were very happy about this. So essentially, for our very small farms, and those are the farms that are making between $25,000 and $249,999, so just below $250,000, you have until January 26, 2024. The next compliance date basically rolls up a year for each of these categories. So for small, which is under $500,000, is January 2023. And for all others over $500,000, it's January 2022. So for our largest farms, they're actually going to start doing their water testing in this upcoming year, in this growing season. So it's one of those things that I think even if you're in one of these categories, probably going ahead and maybe covering that cost over a larger period of time is going to be beneficial, especially if we're talking about surface water.
And multiple sources.
Yeah, multiple sources.
So now we're going to do a few, Shanna? No, go ahead.
Interrupt. So just
Go
for
ahead.
clarification, your baseline has to be implemented with all your data before your compliance dates.
That's right. That's right.
Right.
So you have to actually have that microbial water quality profile. All your 20 samples, if it's surface water,
Or all your
4, by this date. So you actually have to have those numbers generated. So for these growers, they're going to collect data in 2018.
Surface water.
Surface water.
Yeah, you don't want to collect your groundwater yet for 2022.
Yeah.
Sorry. When did they start? Go back to the date.
So
2022.
22. So if you wanted to do,
So 20 and 21, if you're doing, yep.
So you're compliant in 2022.
but if you wanted to do it over 4 years,
4 years. Be
you could go
2018.
2018, 19, 20, and 21. Yeah. So that's why a lot of people are trying to share this cost, especially for bigger firms that have many ponds to pull from or areas to pull from.
Sorry. Two more things for mainly for my clarification too. So in here, when it talks about your results being higher than expected, the rule actually has the limits in there.
That's right.
Just
So it's the 410 for the statistical threshold value
And the
and
126.
126 for your geometric mean.
and then before you get your baseline done, so let's say you're doing, I'll do easy math, for 2 years, you're doing 10, you're still having to react to those results if they are higher, or you, each time you get the results, or are you waiting till your baseline's done?
So it would be in your best interest to go ahead and try and figure out why those high numbers are coming in versus like,
And
oh,
address
I'm going to
it.
sit on my thumbs for 2 years and say, oh, all of a sudden I have this huge
Whoops.
issue
Yeah.
and I've been in production. And I think that makes sense from a common sense standpoint more than anything because ultimately those high numbers are indicating you could have higher risk of making people sick. You have a question?
So if I drill a well or build a pond in 2024, do I have to wait 2 years of test data before I can use this well?
No. You actually can begin. So the question was, if I drill a well in 2024 or get a retention pond pulled together for my farm, do I have to wait 2 or 4 years or 1 year before I can even start using it for production? No. You actually can start using it ahead of time, but you're going to need to start collecting data on that as soon as it goes into production.
Then you need to test from the beginning. Right?
Yeah.
So
Yep.
if you dug a well in 2024, you would want to test before you started using that. But you obviously can't have that full water quality profile that you would start when you started using it.
Yeah, you're going to get that initial sample, and then you'll continue to test throughout the season. By the end of that year, you'll have your 4. Any other questions on this part? It is confusing. Lots of moving parts.
Yep.
All right, so now we're going to talk about evaluating risk. This is example 1. What is your water source? We have a surface water source. How do you apply that water? We apply it overhead. So we're using a direct water application method. And when do we apply it? Near harvest. What is our risk? High. Yep. You guys are paying attention. You're not just here for the good food.
So with example 2, we're still using surface water, and we're applying it through drip. So no direct water application for this crop through surface water. And we're still applying it near harvest, and it's irrigated up to and during that harvest period. So what's our risk? Do you know?
I'm hearing moderates.
So y'all are not gonna take. So have we given you enough information? No, you're saying no. We haven't given you enough. Why haven't we given you enough information?
What else do you need to know?
What was the baseline of the
You want to know the quality of the baseline of the water?
quality of the water?
Well-
Only thing you can say on this is it's less invasive or less risk than the previous one, but you don't have anything to base it on from that point.
Well, I don't know if we've told you everything you need to know necessarily. Do you know what crop you're growing? What if you're growing carrots?
It's going to be riskier.
Yeah, it's going to be riskier. So it depends on what you're growing then, right? So if I'm growing tomatoes, definitely lower risk. If I'm growing a root crop, then it's still going to be
Maybe not.
contacting that crop.
All right, so the record keeping. You want to keep required records, and those are going to be the findings of the inspection of your water system, so that you went through and looked at all of that. Your water test results, any monitoring of your water treatment that you may need to do, corrective measures if you're taking any, and then scientific data or information to support your compliance, including your treatment, your calculations, and your testing. And then scientific data or information to support alternative indicators, criteria, or sampling frequency.
So on the realm of things that you're going to do as a grower, you're probably not going to be doing this last one.
Nope.
That would be like saying, I'm not going to use generic E. coli. There's this other great thing out there, and I'm going to use it. That's not in your wheelhouse. But
Not a good idea.
Not a good idea. There may be another indicator that comes up, and we may be able to get it vetted. And until that time, though, it's probably best for you to stick with generic E. coli. Again, all that compilation of that data and looking at, okay, what is my statistical threshold value? What is my geometric mean? That you're actually reviewing those numbers and signing off on that. Water treatments, which John Buchanan will talk again a lot about after lunch and kind of introduce you to what's an EPA registered device versus a chemical treatment, and so you'll know all about that. But again, trying to make sure you have all this information, even if you don't have to be compliant with the rule, is going to be helpful, because we have seen issues even on very small scales pop up with irrigation water and outbreaks.
So, summary. The contaminated agricultural water has been implicated in some foodborne outbreaks associated with fresh produce, which is why we're talking about all this tonight. Knowing your water quality long-term with testing will help you establish and management practices for appropriate use of that water. If the water is not applied directly to your crop, to the harvestable portion of the crop, the risks are going to be lower. And then extending the time between that last application of water and your harvest can help reduce your risks, especially if that water quality is a concern. And then treating your water is another option to reduce risk as well. You want to keep all the copies of your water test results and then document any water management practices that you're using. This is the last one between you and dinner.
So we have if you're thinking, I don't know about this, I feel a little bit overwhelmed, there are definitely resources for you. So down here, I would say definitely shoot us an email. Actually, I'm going to be leaving for Washington State soon, but so shoot
me
it
an
an email and say, hey, I have questions about trying to implement this on my farm. We also see, though, that we have a really great resource center through the Southern Center, which is essentially Tennessee's part of, and Annette and I both participate in. But we are all focusing on trying to get training materials and resources pulled together for growers in the Southeast so they can be compliant with the rule. And even if you don't have to be compliant with the rule, but feel like it's your best approach for risk mitigation, trying to do that. So that is that top email address up here. The Produce Safety Alliance, which is who developed the primary curriculum, that again, as Annette said, is FDA recognized, is an aggregate of a lot of different members, but is based out of Cornell University, who has taken over lead of that training curriculum. There are also state associations, so the Tennessee Fruit and Vegetable Association would be a good example of one here locally. The Georgia Fruit and Vegetable Growers Association, even though they're in Georgia, they have a lot of really great dedicated resources in the area of food safety. So it may be worth joining their association, even though you're in Tennessee, to see what materials they're releasing as well. And that's that gfvga.org.
And one thing we didn't mention, on your USB drive that we gave you, we have tonight's presentation as well as a food safety decision tool that we worked on with Cornell and the University of Minnesota. And so in that, it gives you language for your food safety plan as well as logs to capture a lot of the things that we talked about here tonight. So you don't have to start these logs of what you monitored and things from scratch. They're all on that USB that you have in there in Word document form, so you can go in and tailor them to your farm. Any lingering questions from this section? It's a lot of info. Jean.
You touched on, additional water, but for some local farmers, they just use what they call dry land farming, no irrigation water, anything else.
Mm-hmm.
So I know you can't measure rainfall, but are there any other precautions that you should be aware of and runoff that may contaminate any produce?
Of course, there's always, yeah.
Out of the ballpark.
Yeah, so the question was about if you're doing dry land farming and not using any supplemental irrigation. Generally, if you're dry land farming, yeah, you could have some issues with runoff depending on what the neighbors are doing around you, or depending on what else you're doing on your farm and how it slopes and all of those things. So you definitely want to consider that. And then even if you're dry land farming, you're generally using sprays on there. So you would have water application with those sprays, so you want to be thinking about that. So even if you're not irrigating, there are issues you can be thinking about.
Along that line, just to hypothetical, it's not all right. A lot of times you'll see people saving water from runoff from roofs and everything. Is that considered surface water?
That's a great question. It is, because
Repeat the question for me.
so he said oftentimes you see people saving water off of roofs and such. What else likes to roost on the roof? Birds. And they make their deposits, and then that rain comes and it's collected in that vessel, and it's going to have all sorts of critters in it. And Faith actually did some work on that as well, catching water off of a high tunnel.
Yeah, we caught it off high tunnel and sampled over an entire growing season, during the basic summer months. And what we saw is that we were always able to get salmonella. You could also get some of those Shiga toxins, the bad E. coli in that water. So we could definitely, because the water actually gets heated more than it would a lot of times if it was just a big body of water, because it's fairly concentrated and
Yeah, it's in a
small.
tank, and often the tank is black, so you don't get algal growth in there. So that black really keeps the heat in as well. And when John shows you some of the treatment options, putting a UV filter on something like that will take care of the water, clean it up. So, I mean, you don't have to necessarily stop using it, but you want to be aware that there are things in there.
One more question?
Does a first flush diverter help with that at all, or
I don't know if anybody's done an actual study on that, but he's asking if a first flush diverter would help with that. And John Buchanan is shaking his head in the back, so no.
We have done studies on it, but it's not been from a food safety perspective, but the microbial load that comes off of a roof really doesn't have a first flush.
That's true. It's not really going to have a first flush. And that's why we're letting that water run when you're taking your sample to get that first flush out. But yeah, in this situation, it would be all throughout that water if you have salmonella coming off the roof. You wouldn't get it out in that first flush.